In number 6, we're going to take the left side and see if the conjugate will work. So we're going to take secant on top, secant minus tangent. And the reason I'm trying the conjugate is because we have something minus something. So it's possible that these all turn into fractions. If conjugate doesn't work, we'll try fractions. But I want to see if the conjugate will work for this to get to where we want to go. So we'll do secant plus tangent. We're just changing the sign in the middle for the conjugate. We need to do that to top and bottom. And then what happens is, since I want secant squared, I'm going to go ahead and distribute secant on top. So that gives me secant squared plus secant tangent, which is what we want. However, on the bottom, we're still going to have to get rid of these. So secant times secant, we're going to FOIL. And secant times tangent. And negative tangent times secant. And negative tangent times tangent. And then when you collect like terms, your middle terms cancel. And then when you look at your Pythagorean properties, if I look at this property, if I subtract tangent to the other side, I will have secant squared minus tangent squared, which is what we have, and that equals 1. So that means this leftover secant squared minus tangent squared is a 1. You can put over 1 if you want, but that is the final step. On number 7, it looks like we should start on the right side because we've got subtraction, and that gives us more to do than over here when we're just multiplying. So what we're going to do is look for what they have in common. Since there's higher exponents, that clues me in that I want to start factoring. So if I take out 3 sines, so a sine cubed, that is what they have in common. And then what would be left is we're taking all those out when we divide it out. So that's just a 1 minus. When we take out 3 sines, there's a sine squared left over. And then 1 minus sine squared, that becomes cosine squared. And that's what we wanted to prove. So that was it for that one. Just factoring it out and using Pythagorean property. On number 8, again, we've got exponents, but it doesn't look like I can factor anything because it's not a difference of 2 cubes, it's a sum. So instead, what I'm going to do is change these into fractions and see if that helps. So we're going to take secant and change it into 1 over cosine, and we're going to take cosecant and change it into 1 over sine, but they're going to be squared since they're squared. I'm going to get common denominators. So I'm going to give this first fraction a sine squared. So it'll be sine squared on top and then sine squared on bottom with a cosine squared. That is already there. Plus this other fraction, I'm going to give it a cosine squared on top and on bottom. So again, this is so that I can get common denominators. And now that they have matching denominators, we can add the fractions together. So you've got sine squared plus cosine squared on top. And we've got that common denominator, sine squared, cosine squared on the bottom. And then on top, what you'll see is a Pythagorean property. So if you look at your Pythagoreans, you're going to see cosine squared and sine squared make 1 when you add them together. So 1 on top. And then we have 1 over sine squared, and then 1 over cosine squared. If you look at your reciprocals, 1 over sine squared will change into cosecant squared, 1 over cosine squared will change into secant squared. So then you're going to get your secant squared and your cosecant squared. Here, you are going to factor the top because you've got higher exponents, you've got a trinomial, but what I recommend is changing it into algebra first. So if we change this and get rid of the cosines, just leave the x's, we can see that it's a quadratic trinomial, and you want to put it in descending order. and then you want to factor out a negative because you don't ever want to start with a negative. Then you want to multiply first times last and look for your factors of 4 that will add up to 3 in the middle, which would be 1 and 4. So you're going to have positive 4, negative 1 to make positive 3. So that'll be x minus 1 and x plus 4. And then there's a 4 in front that you want to divide by. And so you're going to have negative 1. Since 1/4 doesn't reduce, move 4 in front. Since 4 over 4 does reduce, go ahead and reduce it. And that's how it fully factors. You can do whatever factoring method you want, but that's what I've been using for the past couple years. And so then we're just going to put cosine back in. And then on the bottom, I don't want sine squared. I want something compatible. So I'm going to change this into its Pythagorean property. If you look at cosine squared plus sine squared is 1, I can subtract cosine squared to the other side to get sine squared by itself. So 1 minus cosine squared is what the bottom will change into. Now that I've changed the bottom, I can factor it into a difference of two squares. Which will be 1 plus cosine and 1 minus cosine. Then your 1 plus cosines match, so they will cancel out, and we're getting closer to what we want. We have the denominator that we want. We almost have the numerator if it were just negative and positive, so that's why you want to distribute your negative 1 back in on the top, which will make it a positive 1. This will make it a negative 4. And then over 1 minus cosine. On number 10, we've got higher exponents, so this is a sum of cubes. We're going to do sum of cubes formula, which you can go ahead and put on your note card if you don't have it already. And so the a in this case is sine a, so we're going to put sine a for all these a's. The b is cosine b, or cosine a, so go ahead and put cosine a for all the b's. So then we are going to have sine squared minus sine cosine plus cosine squared, and then all over your denominator. Then we see those denominators cancel, and then you see that we have this middle term that we need to keep, but we have this extra 1, and that's because sine squared and cosine squared are Pythagorean, and they make 1. And so then you already have what you need. So all you had to do was factor it, but you needed to know how to factor it. So you're going to use the same thing on number 11. You've got two things being cubed. So basically what we have here is we have an a cubed minus b cubed, which is, and you can put this on your note card, a minus b, a squared plus ab plus b squared. And the reason I'm saying this is cubed is because this is really cosecant squared cubed and cotangent squared cubed, and that's how they're getting 6. So that means my a's are cosecant squareds, and my b's are cotangent squareds. So that'd be your first factor. Then you have cosecant squared squared. You have positive cosecant squared cotangent squared. And then you have plus cotangent squared squared, which would be to the 4th. And then if you look at your Pythagorean properties, you've got cosecant squared and cotangent squared make 1 if you subtract cotangent squared to the other side. So cosecant squared minus cotangent squared is 1. So that equals 1, and you can just kind of get rid of it. So you have cosecant to the 4th, cosecant squared, cotangent squared, and cotangent to the 4th. And then we see we don't have any fourths. So we're going to take cosecant to the 4th and change it into cosecant squared, cosecant squared. Leave this middle term alone. take cotangent to the fourth and make it cotangent squared, and then fill in your Pythagorean properties for these. So I've got cosecant squared is cotangent squared plus 1. Cotangent squared plus 1. Then you've got this cotangent squared here, if I subtract 1, is cosecant squared minus 1. And then you're going to distribute into those parentheses. So you're going to have cosecant squared, cotangent squared, plus cosecant squared plus 1, which is cosecant squared, plus you have this one, cosecant squared, cotangent squared. Distribute this one, you have cotangent squared, cosecant squared, and then minus another cotangent squared when you distribute. And then you will see that we have 1, 2, 3 of these where they're being multiplied, and that's what we want in the answer. They wanted 3 of those, so we have those. And then the leftover is that and that. Cosecant squared minus cotangent squared to the other side is 1. So those make the 1 that we're looking for. So now we have 1, and then we have 3 of the cosecant squared, cotangent squareds.